Back again. Oh, the clock. Would you believe this clock normally refuses to strike and is very temperamental until the moment a camera starts rolling, off it goes. I've marked on the circuit diagram components that have high tension current on one side of them and an earthy connection to the other side of them. And these are all the ones that we should suspect at this stage could need attention in order for the set to be run safely. Cuckoo going on in the background as well. Now, this first one, C33, this incidentally is the circuit diagram symbol for a capacitor. Now, a capacitor is a component that won't allow direct current to flow through it because there's an electrical insulation within it. That's why the symbol is like that. It's sort of like two dead ends, but very close together. Alternating currents can in circuits with capacitors can dodge around them because the current is going one way, then the other way, one way, then the other way, one way, then the other way. So they don't present a stoppage to an alternating current as they do to a direct current, which simply encounters this break and stops flowing. The purpose for this, and it's connected between this chassis and one side of the mains, is if there's any radio frequency interference in the main supply, it will short circuit it down to the chassis, which is the radio's earthy connection, and it won't allow this, therefore it gives this radio frequency interference a means of escape so that it doesn't flow into the anode circuits of the valves that the rectifier is feeding. Now, because it's got mains on one side and nothing on the other, it's, if these components of these days were made of wax and paper as the insulating materials, and over time the insulating qualities of them can deteriorate, and if direct current does start to leak through them, problems can arise. Now, actually, in theory, there's no direct current on this, it's only alternating current anyway, but if the insulation is poor and electricity starts to flow through those, they get hot and they'll just fail, they'll burn up and allow a very serious short circuit between mains and the earthy side of the set. I think we should change that without even querying whether it's in good condition or not. Now, these components, again, they're capacitors, but they have a plus and a minus. Now, capacitors normally don't have a plus or minus because they're the same each way around, more or less. If we're going to get bogged down in technicalities, there's an argument to say that they're not, but to all intents and purposes, at this stage of the learning process, they're the same both way around. These capacitors are very important parts of the power supply. These are for HT, high tension smoothing, and I'll explain a bit about what that is when I can grab a pad and a pen. But these are sensitive as to which way around they're connected, and these act as sort of reservoirs for electrical charge that's coming out of the rectifier, bearing in mind that the AC mains is producing a plus, a minus, a plus, a minus, a plus, a minus at 50 cycles a second. We want a direct current for the valves. The rectifier only conducts 1/2 of the cycle, because here the two anodes are strapped together. So whilst the AC coming into the valve is sort of that, what's coming out of the rectifier to the set are bursts of direct current, because for half the time there's no direct current being produced. So it's current, no current, current, no current, current, no current. Those bursts charge up these capacitors, and the demand for current from the set, which is will be travelling up there, as it were, that can be supplied smoothly, because when the burst from the rectifier isn't there, the gap is made up by these capacitors discharging themselves. So these are in a continual cycle of being charged, discharged, being charged, discharged, and the result is a smoothed, high tension, direct current feeding the anode circuits of the valves. I won't go into such detail about some of these other things, save to say, oh, that's another electrolytic capacitor involved in HT smoothing, but provided smoothing for some of the circuits later down the set. That's another capacitor there to make sure that any radio frequency interference is bypassed down to chassis. These here in the anode circuit of the output valve are there to, they're called tone correctors, and they alter the quality of the signal being fed through this output transformer to the loudspeaker. That is associated with the tone control. That symbol is the resistor symbol, we've seen that already. That arrow going to it indicates that it is in fact a variable resistor that can be made to change value according to the position of the control. So when you turn the tone control, that resistor is varying according to the position of the control. Right. Now what we've been doing on this set so far is what's called cold testing. You can only do resistance checks on components that don't have electricity flowing through them. It's a static condition resistance, and you can check continuity, you can check insulation, in the sense that the opposite of continuity is complete insulation, i.e. Open circuit. A lot of components are built to have resistances at specific values, and that's included in the data here, and we can check it with the set off. It's very valuable. Resistance checks are a very valuable way of checking that there won't be something go badly wrong when we switch on. There comes a point where we've got to switch on, of course, but we want to just make sure that things are as safe as we think they can be made.